It's Michael Tidwell. Paul.
My last name is pronounced sports.
And Michael B. Casey.
Blocktime.
All right. It's Blocktime, and this is Michael Tidwell.
And this is Michael B. Casey. And with us, as always, is Paul Stortz.
I wanted him to introduce himself. Paul?
He always forgets.
Paul, is your mic
Yes.
off?
Yes, is it on? Hello.
Hey, Paul.
Yes,
Okay.
This show is officially endorsed by Roger Vera and Andreas Antonopoulos. That's the point of the intro.
Yeah,
And
it is.
And that's a good point. We have
Both Roger Ver and Andreas.
So the man we have today with us, Peter Todd. Thank you so much for coming on Blocktime, Peter.
Thanks for having me on.
So how I want to do this, Paul, you're gone a little bit earlier, but let's go ahead and interview Peter Todd. Let's get to know like what he's doing, who he is, what his project is with OTS and everything else he's been doing. And then let's jump into the episode and then talk about like current news and stuff. So let's start off with intro. Peter, give us a skinny on yourself. Who is Peter Todd?
I'm some dude who, way back in high school, had a summer job as a Perl programmer, and that terrified me so much I quit programming to go off to ceramics, and then somehow after all that I got back, so I guess that pretty much sums it up.
So
He's there and back again. The story by Peter Todd.
So talk about your dive into Bitcoin and blockchain technology and
what got you involved? Where did you first see it?
Well, I mean, again, way back in high school, I was playing around with the Freenet project, which is this data publication, highly censorship resistant data publication system, and I thought it was very cool and stuff. And my dad, being an economist, I kind of followed in his footsteps. Like, it'd be really cool to add to anonymous data publishing. Why not some electronic money? And I did a whole bunch of thinking on that project, and I realized it was actually really hard. And long story short, that was kind of my first interest in, what would eventually become Bitcoin. So when I actually saw it, many years later, my first reaction was, shit, I should have thought of that. And from there, I just started doing research and understanding the code better, and got a Twitter account, and this, that, and the other. And I ended up quitting my day job to work on this stuff full time as a consultant.
What'd you do for your day job before you kind of went into what do you call it? Bitcoin consulting, blockchain consulting.
Yeah.
What'd you do for your day job?
I was actually an analog electronics designer at a geophysics startup. We were trying to make a new type of gravity sensor.
Cool. That sounds cool. So did you go to university, or did you just go straight from like high school to working, or?
Yeah, no, I actually went through art school. So
ceramics.
Well, I wound up getting something called first industrial design, and later something called integrated media. Which, long story short, is I made a whole bunch of electronics and computer stuff. And from that, I wound up getting that job in electronics.
So you said it was an art degree. Well, what kind of art specifically?
I mean, they kind of call it integrated media, which in my particular case was art made with electronics mainly.
Cool. So did you do like signage and shit, like weird funky stuff, or? Yeah,
like one of my pieces is literally called 64-bit counter, because it's a 64-bit counter with that displays the amount it's counted on a big LED thing. And the somewhat creepy thing about it is you can actually see the computer counting, or to be exact, you see a blur of nothingness, which has roughly the same time span as your entire life.
Oh, okay.
That's my artist statement. Very formal.
Wow.
So how are you so popular? I'm on your Twitter. You got like 35,000 Twitter followers. What is it that makes you so popular, Peter? Why do people follow you? And I hear a lot of people reference you and all this stuff. What's the secret sauce? Because obviously we don't have it, Mike, Casey, and I.
I think a lot of it is just being able to explain, technical concepts to non-technical people. Particularly from art school, I had a ton of experience doing that. Plus, I also did a bit of computer science and physics, so I've got enough of an actual background to back it up. But I think the big thing was just learning how to explain this stuff and how to talk to people.
If you don't mind, how can you talk about some of your first consulting opportunities and what that looks like? Because you're what year was it, and was that kind of just being forged as like a Bitcoin or blockchain consultant? And would you consider yourself one when you started doing it?
Well, when I started, that would have been, I guess, quit the day job in 2014, like early 2014. In my first kind of intro into it was I'd gone and wrote up a scathing report on why I didn't think Mastercoin would work, and the people behind Mastercoin responded by hiring me as their chief scientist to go and figure out how to make it better.
Come on, Mike.
So, what other projects have you worked on besides Mastercoin? Were you were involved in Vertcoin, was it, or was that one of them?
No, not Vertcoin. I also did some consulting work for Counterparty. Analyzing their stuff. Prior to becoming the day job, I did some security analysis for Litecoin. Verifying their rebase to Bitcoin Core.
So this was after when they did their upgrade after they languished for the number of years.
Yeah, exactly. Yeah. And more lately, like working actively on stuff like open timestamps and proof chains.
Yeah, definitely. We're going to be talking about.
Oh, also, you were the progenitor of the tree chains concept, correct?
Yep.
Can we talk about what is that?
No, well,
sure.
Let Peter talk. I was going to explain it, but no, you
explain it. Let Peter talk about it because he did it, right?
Yeah, it's his thing.
Well, I think in summary, the highest level way I can go put it is it comes from a realization that you can go shard consensus much more easily if you don't require everyone participating in consensus to validate each other's work. And then the flip side of that is the tree chain idea then is reliant on client-side validation, where the user who's actually, say, accepting money in the system, they have to verify the transactions themselves.
Okay, so you're offloading the burden on the client side versus the main network
for processing for validation, right?
Exactly, yeah. And the high level concept behind that is the person who cares whether or not their money is real is the person receiving it.
See, that reminds me a little bit also. Mimblewimble acts the same way, right? Because it's not actually in the blockchain. It's by
although it uses clever math tricks to still do full validation for everyone.
Okay, so
it's more that the data storage side of Mimblewimble gets to play that trick.
So what is a use case or whatever of tree chains or whatever? Like, is that happening somewhere?
It's sharding, isn't it? So you can.
It needs a ton of work to actually make it happen, but the use case that was envisioned for it, and I hope to one day actually implement, is essentially electronic money.
So it's a better version of. I don't get it. Is this going to be like a competing idea with Bitcoin, or is this going to be like a?
He's asking what feature set. Yeah, so an upgrade. He's asking what feature set does it add to Bitcoin?
Well, scalability. I mean, at a quite direct level.
So hey, Paul, are you listening? You've been quiet.
I am. I'm listening. Yes.
Okay. So what's better, tree chains or drive chains?
Well, actually, it's funny. I think all there's like a big overlap with the sharding concept, which is that it is really hard to have everyone validate everything. So what if we just don't do that? So that's an area of overlap, and I'm not sure. Peter and I actually discussed this at Scaling Milan, and I remember being confused about like they're very similar, and I'm not even sure where even the differences are, because if you want to have a scheme that has transaction fees that are paid in Bitcoin, or that the miners, because as Peter says, the only person who really cares is the person who's getting paid. They want to know the state of the money. But if miners are getting transaction fees, then they're the ones getting paid. And it was not clear to me at the time, having not really looked into it very much, but it was not really clear to me, like, if you would still be proving all this stuff to the same set of miners anyway, and so it would end up being the ultimate consequence would end up being similar to kind of a drive chain, side chain kind of scaling idea.
Well, I mean, I think the key insight there is that you can have systems where I may pay you with funds that aren't actually used to go and get the transaction mined. The funds used to get the transaction mined, they can be chosen in such a way that there's less data that I need to actually prove to the miner to convince them that those funds are real. Now, whether or not this can actually be done, I mean, like I say, it's halfway to vaporware. I mean, there's a ton of other work that needs to be done to make this idea, even get off the ground. But that's your very high level concept there. That's why I think it's plausible that one day I can make this work.
Okay, so it's something interesting. Maybe a couple years down the road or something that this will be a thing, or sooner. But it's kind of like drive chains. It's like one of those things that are nice to have, but we'll never get. Right, Paul?
Well, yeah, but see, so Peter Todd's is like halfway
Just kidding.
to vaporware, so mine is like halfway to
Production.
be finished. So it's halfway away from vaporware.
Oh no, I'm kidding, Paul. Or at least I hope I'm
Is
kidding.
the glass half full of vaporware, or is it half full of liquidware? Is it half full of liquid thermite?
Poor, rest in peace, Samson Mao.
Yeah. Well, Lady Melisandre is going to bring him back.
All right, so
Peter was going to say something.
Go for it, Peter.
The interesting thing about the ideas behind tree chains is that in a centralized environment where all you're trying to do is just make a centralized blockchain scale better, they're actually relatively easy to implement. And I mean, that's what I was working on at R3. I was supposed to be making that actually happen, and as far as I know, Corda is still going along that path.
Interesting.
And I'm still working on
so they're
my
sharding
all the good ideas from Peter Todd.
Well, I mean, how does this? Hey, Peter, can you? I mean, if you're going to go to a centralized system and do sharding, can you explain how this is different than maybe normal? I don't know. I mean, I know that you said this is specifically about consensus or whatever, but how is this? I mean, if you have different shards and you have different people who don't care about what's going on, they only care about what's going on the relevant shard or data or whatever that they need. How is this different than any other kind of distributed kind of sharding system? Or is it? Is it just a better version? Or
well, the interesting thing is, I don't think you actually necessarily need consensus. My argument for this is actually quite simple, which is that, if you have a transaction history, all right, and I can show to you that there's some history associated with some coin, showing it move from the Genesis block, when it was created off to you. What you care about is, does there exist an alternate history? Because that's, ultimately the thing that prevents inflation, ensures that you're actually getting, a real coin. And every step of that process, all you have to do is prevent that action from being taken twice. And I've kind of modeled this as something I call a single use seal, which is that if you imagine we had some magical cryptographic structure, cryptographic gadget, if you will, that had the ability that it could only be triggered once, could only be sealed around something once. That would be sufficient to prevent double spends. Of course, the hard part's actually making that gadget. But if you do have that, it's easy to imagine how these systems can work, and also how they can go scale, because my coins, and your coins don't need to share any of that state. You can do a transaction, closing seals on your transaction, outputs, and I don't need to know about that. We know in a trusted environment we can implement this with, trusted authorities that go sign messages, signifying single-use seals are closed. So obviously we can make this scale in the real world.
Yeah, with trusted entities, it's easy. But I mean,
Yeah.
But I think the purpose of consensus is even if you're only looking at one particular path of one particular set of outputs or whatever, there has to be consensus to verify that is the only or the accepted path, right? Because otherwise, there could be an unknown path to you that could later pop up, right?
Well, the point is, we don't need global consensus for this.
Okay. No,
We
global
only need
consensus
local
on
consensus
on
for a given
everything.
output.
Okay.
Is consensus? Would you say consensus is needed or not needed for distributed systems?
Well, my point is that in this case, you only need local consensus, not global. Right? In the sense that you only need consensus around a particular transaction.
Okay. When you say
care about it.
when you say local, you're talking about you only need consensus about a subset of the total number of the entire ledger. Is that what you're saying?
Yeah. I
Okay.
mean, in a way, that's still global consensus. But
Right.
not
It's global amongst
consensus.
all users if they were looking at it, but you only care about what you're looking at, right? Is that what you're saying?
Exactly. Yeah.
Okay.
So in reality, you end up with global consensus, but you achieve it through a system that doesn't have global shared state.
So it's like sharded, threaded global consensus, right? Multi-threaded global consensus,
Yeah.
I guess.
I mean,
I don't know.
here's an analogy. Like currently, we have global consensus on the location of every gold bar in the world, but that consensus is enforced by physics.
Yeah.
It's not enforced by computers. It just is.
Okay.
And I don't know the location of those gold bars, but those gold bars still don't move.
No, that's a good analogy. Okay, I see what you're saying. So nobody has to know the state of everything, but the state of everything can be known by everybody just because it is enforced by the rules of the system.
Yeah.
Interesting.
Yeah.
Well, yeah. I mean, that's one of the fundamental inefficiencies of Bitcoin is the ledger is held in its entirety by everybody, and you're exactly right. Nobody cares about anything that doesn't impact them, except maybe people who are trying to mine data. That's about it. Which is exactly what we don't want. But at least me.
It's unfortunate that we happen to need this for technical reasons, but in the ideal world, you're absolutely right. We wouldn't have this.
Right. It's a drawback, but I mean, it's the only way currently to make it technically feasible. So yeah.
So you're talking about some of you kind of talked about what you're doing at R3. How long did you work there? And then talk a little bit more about what you did at R3, why you left, and maybe what they were doing. Because I know they kind of pivoted, saying that they're going to use blockchain technology. Then they're just blockchain inspired. Maybe you can talk a little bit about that. I don't know how much you can talk about, but maybe I think you said you could talk a little bit about it.
Yeah, well, I mean, I think what I can say is that when I started R3, I was doing an analysis, and that wasn't full time. I was a consultant getting hired to analyze different consensus systems around the world, and I think they had an idea that they would buy, acquire, whatever some of these systems, and of course, very famously, I did an analysis on Ripple.
Yeah, I remember that actually. That was good.
Yeah, well, that was a very interesting paper because, in a sense, it was so easy. All I had to do was accept that what they said about their consensus system was 100% true, and then attack the assumptions it made. And I think many of the critics of that paper don't really understand what I did there.
Okay, let's see.
Yeah, I've never been a huge fan of Ripple.
So you're a big time Ripple lover, right, Peter?
Yeah, I think we can do better systems. And of course, obviously R3 thought that too, given that, then the idea was I was going to go work full time on applying the, proof chains technology that I'd already been working on as, R3 is what's now called R3 Corda. So the actual basis of R3 Corda, I think it's fair to say it was kind of reinvented multiple times. But essentially, I and the other architects at R3, we sat down in a meeting, said, all right, how are we going to do this? We all had roughly the same idea. In my case, I even went as far as to get a contract to go and sell them rights to proof chains so that they would incorporate it into Corda.
As far as the objectives of R3 or R3 Corda, it was to pretty much connect a bunch of banks together in like a common ledger, though, right? Ultimately.
Well, that's the thing. Not necessarily common, right? You know, and you can see this from like R3's discussions these days, where it's always talking about how the ledger isn't necessarily shared among all banks.
Yeah, see, I haven't been following the R3 saga, but I mean, last that I heard is it kind of a little bit fell apart because they realized that nobody wanted to share their data amongst themselves because it was all proprietary.
Oh, no, I don't think that's the case at all, actually.
Okay, so what's the current status? Like I said, I haven't been keeping up.
Well, hold on. Let me answer your first question of why it felt yeah.
Well, so actually, I would say that right from the get-go, you know, we worked very hard to ensure that no, we didn't need to have everyone in the world sharing their same ledger. You know, it was one of my criticisms of Ripple as an example. You know, proof change is designed to not require that. And I think the real thing that happened at R3 was, you know, essentially, I mean, my contract I actually signed with them, it had an open source provision in it. So, you know, the work I would be doing would be open source. And I suspect they, you know, realized that this wouldn't, you know, or at least pivoted their business plan so that they didn't want to do open source. And they want to keep the software proprietary. And of course, the banks probably took one look at that and thought, you know, this is bullshit.
Yeah.
So in other words, is that the reason why you left, or they said, hey, we can't do this anymore with you, or what?
No, they went and fired me. Or to be exact, legally speaking, they canceled my contract. And the claimed reason for that was that I'd gone and tweeted, see if I get the exact wording right. Yeah, so Mike Hearn had posted something arguing
between
that
you and her.
tail recursion was just an optimization.
Wait, say that again?
You know, that tail recursion was just an optimization.
Okay,
and
I don't
his
even know what
argument
that means.
was that without tail recursion, say a system might, you know, recurse and use up, say, you know, 60 megs of memory. But then with tail recursion, it can recurse even deeper. So it's, you know, an optimization that reduces memory usage.
Cool. All right, so keep going.
So, and remember, at the time, that was when Mike Hearn was arguing very strongly that we should all move to Bitcoin XT, you know, with him as the leader of that.
Yeah, I remember.
With Gavin. Yeah, it was Gavin and Hearn who were kind of the two people, but Hearn a little bit stronger, I think.
Yeah. Yeah, exactly. It was right around that time, you know, very, very, very political for Bitcoin. So I went and found this quote and went and, you know, got a screenshot of it and tweeted. The fact that Mike Hearn thinks tail recursion is just an optimization explains a lot of his thinking regarding scaling Bitcoin. And I mean, after all, like Mike Hearn's approach to it was to throw more computing power at the problem. I mean, it's actually, you know, it's quite a valid observation. It fits right in. And, you know, when they heard this, they had a big huff saying, you know, it's all unprofessional and so on. And, you know, they needed to.
I think this is the quintessence of the block size debate right here. Is right. I mean, honestly, I think it is because one side believes in only optimization, and the other side believes in, hey, just brute force.
I mean, I would definitely say Luke Dash Jr., Eric Lombroso, Greg Maxwell are optimization first kind of people.
Well, I mean, even more than optimization, I'd say just I think they accept that. You know, there's limitations to what you can ask people to run. You know, I think Mike Hearn is a very different security model for Bitcoin than you know, the rest of the developers do.
So I haven't heard anything about Mike Hearn in years, or
well,
like
I mean,
at
he
least
dropped
a year.
out of the entire project. But I mean,
is he still with R3?
No, I don't think he is anymore. Right?
I don't know. Is he?
So, no. I remember.
As far as I know, Mike Hearn's still R3.
I remember a release.
And it's
like
quite
a year
ironic,
ago.
actually, because as far as I know, he's continued on my proof chains work, which basically is, I think, a very sane approach to scaling things. So he went from someone who had quite crazy ideas about scaling to actually doing some research I was intending to do.
So Mike Hearn is like this guy who dropped off the face of the earth, who is still where we left him at R3. Isn't that crazy?
Well, the last I heard of him, he published Corda. He like published it and says, "Okay, it's out," and threw it out in the world. That was the last major post I saw out of him.
You got to understand, R3 after that instituted a social media policy to prevent people from talking outside of R3 channels.
Oh man.
Although I think you're right that we haven't heard a lot about from anyone from R3, but I thought Mike Hearn didn't because with the recent he published Satoshi's emails or something, and then I thought I saw him on RBTC, and I was like, this is weird. But that was like in the last month or something.
Yeah, I didn't see.
Yeah, no,
I didn't notice
yeah,
him.
he's still around. Like he's given public presentations on Corda. You know,
So
I think this is just that R3. I think realized that. Well, I mean, after all, Mike Hearn, like for them to say that I was being unprofessional there. I mean, Mike Hearn was calling me a toxic individual who was terrible for Bitcoin, et cetera, et cetera. And R3 never actually paid me, so there was potential lawsuits there. But they still owe me about $15,000.
So Peter, I like.
Did you price that in Bitcoin? Because now it's worth a lot more.
Yeah. I have a question, Peter. So how would you compare and contrast R3's approach for their Corda platform versus stuff that's being done with IBM and Linux's Hyperledger initiative and that stuff? How different is R3 from that style of permission ledger blockchain?
You know, it's not totally clear to me because, you know, like a lot of the R3 terminology and whatnot is being changed from, when I was there and so on. And I haven't bothered, really looking in depth at how the software really works. But I think the main thing is just, the R3 approach, to the extent, it has kind of followed what I was working on, is more modular. It's more based around more granular types of consensus. But I should be careful what I say because equally I haven't looked at Hyperledger that closely. Since
Hyperledger has pluggable consensus models, and it's interesting because one of them that they tout, because I've been through a couple of Hyperledger presentations, they actually talk about on permission blockchains proof of work, which I just start laughing every time I see that.
The idea of using proof of work in a private centralized system is
it's
pretty funny.
It's yeah, really. They put it in there because they have to put it in there. Is why they know better, but it's hilarious.
Well, that's not as crazy as you'd think.
Really? Okay. So how?
If a proof of work chain exists, it makes a lot of sense to reuse that in your own system. That's
okay.
For instance, like what I've done with my single use seal stuff.
Okay.
Now,
Okay.
To go do proof of work for the chain,
right,
is crazy. I agree. But
you're saying utilize a separate consensus model.
Well,
for
entropy. I'm pretty sure the pluggable consensus Mike Casey was talking about was proof of work.
Yeah,
we're actually talking about servers in the same company crunching.
Well, so what's asinine about that is not just that
the hackers can't come in and write data.
Well, no, it's what's asinine about that is literally if you're dealing with semi-trusted parties in a permissioned ledger. And your only recourse is to trust this proof of work chain. All somebody has to do is go out and buy a bunch of shit, and then they can outpace you, and then they can 51% attack the network, which is just stupid. I don't know. It's just funny.
Like I say, this is why leveraging another chain as an add-on to essentially prove things about the state of your consensus makes a lot of sense.
Merge mining, like anchoring, is what you're saying.
Anchoring is kind of the better term there. Although anchoring gets abused in so many ways. It's not a term that has a clear text.
How would you define anchoring? Because that's a good
point. Wait, sorry. How did you define anchoring first, Mike?
Oh, I would say
it's just a timestamp.
Yeah, it's a timestamp of a known state, a hash of a known state of something.
Well, what else would it be a timestamp of?
well, that's it. I mean, anchoring is insufficient to protect these systems. In fact, I would prefer that the term anchoring referred to something that also included essentially double spend protection.
Oh, really? That would be that's a much bigger thing, of course. Yeah. I feel the opposite way. I feel like we should just say anchoring is a very simple thing that's not that, and then some other new thing. Consensus would be the anchoring state or something.
But we already have a term for just timestamping.
Well, I mean, anchoring
implies another term.
Borrow the timestamp from someone else, though. Like you anchor it in Bitcoin.
Yeah.
Timestamping.
Anchoring implies that the timestamp is enforced by something else. It's anchored in the work of a proof of work blockchain.
I think that's all silly. It's timestamping. Just call it timestamping.
Okay. Well, I mean that's
with Bitcoin.
Well, that's God, what is the word? Holy,
but
I do know,
semantics. It's a semantic argument. It doesn't really matter. Yeah,
I don't know.
Semantics matter, though.
Well, it's true.
Keep in mind, I come from art school, where I found finding good terminology and good ways of explaining stuff is really, really critical. You need something that people don't trip over. You need something that gives people a right impression.
Then if you want to get technical, if you want to argue about the semantics, I think it makes more sense to say that it is time stamped, yes, but the timestamp is anchored in the proof of work. I mean, to me, that kind of makes sense because what proves the
timestamp is secured by the proof of work.
Well, that works too. I mean, you could say it's secured or anchored. In my mind, both of those make sense. Yeah. I mean, either one's.
Like I say, anchor is a good term for something that gives you double spin protection, and the reason is simple, which is that an anchor, in physical metaphors, is a thing that keeps you in one place. It prevents you from moving, prevents things from getting changed, which is subtly different than what timestamping does. Timestamping simply shows that something was from some points in the past, but doesn't say how many other things just like it could exist.
Well, that's true.
That's you know what? Hey, real quick. Oh, sorry.
Well, I was just going to say when I do my visualization of anchoring in a blockchain, I'm just thinking of one block stacked on another, stacked on another, stacked on another. When you have your timestamp, you have your anchor. You throw the anchor in between the two blocks, and it gets it stacked on top of it, and then the anchor stays there forever. And then
the problem is that's not actually how the crypto ends up working. The problem is the anchor isn't bidirectional. Like your timestamp isn't a bidirectional proof.
Of course not.
And it's also a proof that can be replicated many times over.
Yeah. So okay. So let's get into the differences. All right. Oh, you had something to say, Mark?
Well, I mean, I want to jump in and say, like, what is our definition of timestamp? Because, like, to me, is timestamp the action of timestamping, like, with like a date and a time, or is it an actual, like, it can be a noun where it's like, this is a timestamp, and it's like it's like it can be by itself and still be a timestamp, or is it more of a verb where you have to timestamp something?
That's ridiculous. Like a saw is a saw of a noun and a verb. It doesn't matter.
Well, no. It might not matter to you, Paul. Hold on. But does it matter to Peter? Because to me,
podcast award.
No, but to me, why
don't we just talk? Let's do right now. Open timestamps versus Tierion.
All right, let's do it. Let's do it. Let's hear it. Let's hear it.
Sure. Paul, you're I apologize for making this the worst podcast.
Let's go
in America.
Let's do this.
It's not. It's also the worst podcast in Canada now.
Why? Let me think in my brain if there are any differences.
So hold on. Okay, let's just do this first. Okay, Peter, can you please walk us through open timestamps?
Yeah. I want to know more about open timestamps. Then we'll jump into Tierion versus open timestamps.
Well, so around 2012, when I was still working full time in geophysics and studying Bitcoin, I realized that timestamping was really, really easy to do. In that the existing solutions all kind of sucked, and they were all centralized, and they were all expensive, and you couldn't really trust them that well. And of course, like many other people noticed, Bitcoin was great at doing timestamping. But what was unique that I noticed was that you could easily make a timestamp proof format that was extremely flexible. So it would adapt to essentially any timestamp system. And however you made the timestamp, you could prove it with this format. So I built that and called it Open Timestamp. And then, added Bitcoin support and so on. And I think, it must have been like 2013 or so, or 2014. And, did a bunch of work on that. But, I had more pressing things to go work on. But, even back then, it did actually, have pretty much the same functionality as it does today. Modulo some differences. The code wasn't as nice and so on. But, essentially the main core of it was all working. And it would prove that, your file existed before a certain point in time.
But that's all it proves. It doesn't prove, that something occurred at any point in time. Like you said, it's not a bidirectional anchor. It just
exactly, yeah. And it's actually extremely difficult to make those bidirectional anchors.
Right, exactly. That's a big problem.
It's a lot less trivial than people think it is. And anyway, long story short is, I guess it would have been about 2015. I had two clients who were interested in using it, and essentially told them, hey, I've got this open timestamps thing, and they liked the idea, and I wound up doing a quick rewrite of it. Essentially, it acted as documentation, so their own programmers could rewrite it, and use it internally. And then, yet another year, like early 2016, I was noticing things like Tierion continuing to kind of develop and not actually work all that well. And I figured, you know what, I really need to go sit down and actually, rewrite open timestamps and make it into a production worthy project, because I actually need this for my own projects, for my clients' project, and no one's making this. So that's
It is a really
exactly
cool
what I did.
idea. And I always want to timestamp things for one reason or another. And I've really had a really much harder time than it should be. And I do all these weird other, I have my own weird custom way of doing it, which I found worked the best. But I was annoyed that no one would just, I just really think it should be as part of Bitcoin D or something, where you can just click a little thing and it just timestamps something, and it's just very simple. I think it's a great idea. As you say, it's easy to do as far as resource requirements, and it's useful. So I don't know why it wasn't more useful.
Well, it's very small there, but I mean, if you're talking about at scale, if you're timestamping a whole bunch of crap and storing it at a place, you probably need a slightly more robust system just to manage the stuff that's being timestamped, so you don't lose it.
That's exactly what Open Timestamp did. All the way back in 2013, which is I had the infrastructure through a centralized set of calendars that you could do timestamps for free, and all the world's timestamps would get timestamped with one single Bitcoin transaction. You get your proof back, and so on. Now, there's some technical details that I think the current iteration is much better, but essentially that's the idea there. And because timestamps scale,
so who
they
pays?
can be essentially free.
So who pays for the transaction fees of the transaction that stores the Milk root of all the timestamps?
I'm just paying it at a donation.
Okay, so
the cost for it's tiny.
How often do you timestamp then? I mean, if it's donation based, I'm guessing you don't want to timestamp every block, because you'd cut through the funds faster. So are you doing once a day, once a week, or once every couple blocks?
It winds up being a couple times a day.
Okay. Essentially,
it targets a certain amount of money being spent per day. And if transaction fees are lower, it timestamps more often. If they're higher, it timestamps a little less often.
For a lot of use cases, that's perfectly adequate. I mean, if you just need a daily timestamp, then that's all you care about, is it happened somewhere around this day, right? So
the thing is, Bitcoin block times are kind of dubious anyway.
Oh yeah, there's a distribution for one, and two, they lie about their times.
yeah. There's a lot of technical reasons why you can't get particularly good resolution with high accuracy on Bitcoin. And the other thing too is nearly all timestamp applications, all that matters is that you prove something was somewhere in the past. To within a month is usually good enough, because you're just trying to say, hey, this data that I now have suspicions about, let's make sure that it's well in the past, not, maybe the recent time when I think that data might have been changed.
Right. And it depends on the application, but I would agree, most of the use cases don't require that level of resolution. Yeah.
So what does the calendar give you as far as OTS? What does that, as far as granularity goes? How does that work?
Well, so the current version of Open Timestamps, the calendar is not there to provide granularity. It's there to make it, to make the timestamping process as close to instant as I can. And essentially, you can make a timestamp that you'll be able to verify indefinitely into the future in about a second. And the way that works is the calendar is essentially taking every timestamp request in the world to it, aggregating one Merkle tree, and then saving the tip of that Merkle tree indefinitely.
Yeah.
And at the end of that interval, it gives back every client, either directly or through, a hierarchical layered set of servers, if need be, they're part of that proof. So essentially, they get a path up that tree, which is sufficient for them to show that their data was committed by that Merkle tip.
So how is that different than Chainpoint, or these share very common aspects?
Sounds very similar.
Yeah.
Well, let me explain the second part of this, which is
sure
that once you then put like these Merkle tips, I call them commitments, and then the calendar is making a promise to do two things. One is eventually timestamp that, in Bitcoin or whatever other chain, and two, make the timestamps of the commitments available indefinitely. And because that's, you know, a trusted centralized system,
That's, I mean, yeah, if the
calendar-
process goes away, say the entire thing goes away, you still have to be able to verify old timestamps. Yeah, so you have to have a facility to do that.
Well, yeah, that's the thing. So half that data structure is sort of ephemeral, stored by the clients. And then the other half, which is actually, of course, a very small amount of data, you know, the tiny amount, is kept permanently. And then the calendars then also make that available publicly for mirroring. So you can get full copy of all the calendar data. And then we, on top of that, then have redundancy. So, you know, currently we have 3 different calendars, and I'm hoping to get that up to about 5 in the next 2 or 3 months.
Are each one of those servers developing their own Merkle root, or do you have some kind of consensus or, you know, aggregation between all 3 of those servers and then make like a master Merkle root that does a commit? How does that work?
So the interesting thing about timestamping is actually consensus makes it less reliable, because you only need one server to successfully, you know, complete the task for the timestamp to be valid. Whereas any consensus system just can't tolerate, you know, as many servers failing.
Well,
You know, it needs a quorum.
I mean, regardless of, you know, servers failing, because I mean, I work in a big data, you know, company where we have tons of services, and you know, we want consensus, and hey, you know, these 3 servers fail, we spin up 3 new ones, and we constantly are monitoring that. So why is it? I don't really understand. To me, it sounds like you have each server doing their own anchor. I don't know if that was an acceptable term, but it has like its own peg to the blockchain.
Well,
So
the point is, each server is making the calendar data independently. Now, currently, they all do their own transactions, but that doesn't need to be true. You know, they can actually, use each other's transactions. But I haven't bothered implementing that because, you know, I just don't spend enough money.
I mean, isn't that a tough problem to have without consensus? I mean, that's hard,
well,
right?
it's a lot easier actually if you don't need consensus, because you can deal with failures by just doing your own transaction.
I guess, I mean, so me coming from like a centralized, it's funny how I have to caveat it that way on this podcast, but me coming from like a centralized, you know, big data background, consensus is everything. So, or, you know, consensus is important. Why, you know, between like a bunch of servers and stuff, why are you brushing it off so easily that, you know, consensus is important? I don't really understand that. I might not understand like where you're coming from on that.
Well, I mean, the answer is simple. For the use case of open timestamps, I don't need consensus across the calendar.
But isn't that more expensive? Because now every single server is doing their own timestamp instead of aggregating between all the servers.
But my point is that I don't need client-side facing consensus. Now, I can use very unreliable opportunistic consensus, or, you know, opportunistic cooperation. For instance, you can imagine one server being, you know, called the leader, and everyone will just use it for timestamps. And if they time out, they just do their own transaction.
So hold on,
Yeah, that's a very simple system.
1 second. So let's just so that's open timestamps as a platform. I think, Michael, you know the best about Tierion. If you want to describe it as best you know.
You know, Peter Todd might know.
Compare and contrast.
I'll be honest, Peter Todd probably knows Tierion better than me, because I haven't actually used Tierion since they've implemented their calendar system. So
how would you compare and contrast open timestamps to the methodology of Tierion, which is the biggest name I could arguably right
Stampery.
now?
Hey, hold on. Actually, let's ask, who is your biggest competitor, Peter? Is it Stampery? Is it Tierion? Is it someone else that we don't know about, like Verity? I don't know. Like, maybe you can talk about that. Guard time,
I mean,
maybe?
It depends a lot on what user you're actually talking about. I mean, for many of the users of open timestamps, there are no competitors, because all other systems are commercialized to some extent or the other.
Right. Okay. So I get the distinction of open source versus some sort of commercialized system. But my question is, other than that, what are the differences?
Well, hold on, real quick before you finish. A lot of these things are also open source. They're also corporate. They're corporate, but they're also open source. Yeah.
Right. Well, I mean,
you
FOSS. Sorry,
well,
FOSS
I mean,
versus
what's FOSS?
Free open source software, like as a methodology versus like a commercialized thing, like Linux. You don't pay Linux anything. You know, it's like
Okay.
I don't know.
All right. Anyways, so in other words, I don't pay anybody anything to use open timestamp. It's always free forever.
Exactly.
Okay.
You know,
Okay.
and
That's
the
I
simple
think that's
reality
what he's
is
talking about. Okay.
timestamping is so cheap that, you know, I think I can go pull this off indefinitely in much the same way that Let's Encrypt works.
Through donations, right? So
Yeah.
essentially, donations will be able to sustain the lifetime supply of timestamps if we're using like aggregation services like Open Timestamp.
Yeah, I mean,
Okay.
point is, this stuff's pretty cheap.
I mean, essentially, it's a Bitcoin transaction fee every so often.
Right. It depends on the resolution desired.
Yeah,
I
mean,
guess.
if you're
And-
trying to do timestamps every single block, then maybe and block size doesn't increase, and we keep like a lean, mean Bitcoin machine, then maybe that isn't true. If you want like super granularity, but
Well,
maybe like once a day, it is true.
I mean, when you look at, for instance, the budget of something like Let's Encrypt, as Open Timestamps grows bigger, the point is the amount of money available for donations goes up. And frankly, it would be a long time before transaction fees went up enough that the value of people's time volunteering for Open Timestamps was worth less than fees. Plus, I have a good solution to get rid of fees entirely with SecP 256 commitments, which basically lets anyone who's already doing a Bitcoin transaction timestamp for us.
Oh, okay. So like it would be a voluntary checkbox that you throw into the client where they do that and says, "Oh, by the way, put in this operator."
Pay an extra 80
Well,
bytes.
I've been
or
talking
whatever.
to some people who already have reasons to do tons of Bitcoin transactions, and some of them at least are quite interested in helping us out there. So
That's actually an
I
interesting
don't think it's a huge
concept.
deal.
You're crowdsourcing the.
Yeah, I would do that. I
crowd-
would check the box. I
Well,
would do
exactly.
that.
You check a box, you pay a couple extra cents, and
Well, you'd pay like, let's say, like right now with fees, maybe like 50 cents more a transaction, right? Because it'd be like 80 bytes more, right?
It's even better than this. There is no marginal increase in transaction size.
I mean,
the
you're adding an
commitment
op
works
return, right?
Nope. The commitment in
interesting. What?
SecP 256 commitments is done in the signature. And doesn't add any
it's in the
extra size.
signature, so it doesn't change the size of the transaction. That's very interesting.
Exactly. Yeah.
Wow,
Yeah. So,
So it costs
Ultra,
user
has
nothing.
already written up an
that's
implementation.
very interesting. Wow,
Yeah.
that's cool.
is I think that's also what Tierion moved to too, right? They used to use op return, but now they're using the signature or
No.
whatever.
No.
Okay.
No, actually, apparently they were trying to get a Blockstream to help them implement it, but they essentially couldn't figure out how to do the math. So
It's just the math was just too complicated. They need Vitalik, don't they?
Well, is this something that's up and running now, or is it something that's still a work in progress, or what?
basically, there's a pull request to the Python Open Timestamps library with working code from Andrew Polstra, and I'm planning on merging it once I go do a second implementation in Rust. Essentially, I want to get some peer review on it, but we know the math behind this works. It's used for other stuff, so there's really no question that we can
That's
do this.
actually a
Wait,
pretty. Cool
are we talking
approach.
about? Are we talking about including it in the signature data?
Yeah. So basically,
But
the
it's not.
signature.
So it's not live yet.
Well, no, it's not.
So you are using op return right now.
Yeah. Right now we're using opportunity.
Oh, okay,
It's
okay,
not.
okay.
It's
So
not
this
live
is a
yet, but
planned
he's saying
upgrade.
it's fully baked.
Okay,
It's
so
not live, but fully baked.
So Peter, if you pull this off successfully, I mean everyone will just copy you because it's open source, right?
Of course.
Yeah, they probably will.
So
I think that's his goal, right?
I mean,
Imitation
no,
is
I'm
the
just saying, like,
sincerest form of flattery.
yeah.
Well,
I mean,
like the funny thing about this whole feud with Tierion and all that silliness is, I spent a lot of time trying to go convince Tierion to do exactly what Open Timestamp was doing. Because I didn't want to have to write it myself.
Yeah, but writing it yourself was the best way to convince them.
Well, usually is.
It seems to be.
so Peter Todd made the best company, the best timestamping service ever, Tierion, because he promoted
Tierion didn't do it very well. Like
What
He-
is
he pushed
what is-
Tierion
what
to
is
do
your
it
cut
right.
of the ICO.
yeah. Hey, Peter, give us the. Be
How much
honest.
TNT
How
were
much
you
TNT
issued?
do you own, Peter? Be honest with us.
yeah, none. In fact, Tierion, even though they said they would, they didn't even give credit in the Chainpoint documentation for the fact that it copies Open Timestamp model basically. So kind of annoying.
Whoa,
Well, I don't know a lot about that, but my understanding is that my guess is that he would say something like, they've been working on it transparently for a while, but you kind of like didn't work out until since 2014. Then you kind of worked on it secretly or didn't tell someone or something like that.
So hold on,
I
just
mean,
say, wait. I don't want to
it's
get too far off skew because honestly, if we're gonna have this conversation, we should have
Yeah.
like Wayne Vaughn on.
We can.
Yeah,
well,
yeah.
hold on. We can interview Wayne and his team after this, so that can be next episode.
I know it's
That
finally
would-
getting
that would
good.
be
You guys
kinda
like
funny.
Let's talk about let's hear
it as
let's
possible.
yeah. I mean, we're all
That's the plan,
Well,
Paul.
I haven't-
we can get back to some like hard tech, which is actually like what they've claimed in their ICO.
Yeah. So talk a little bit more about it. So I'm kind of ignorant about the most recent advances in the timestamping technology. So what tech did they claim?
Well, so there's really one major claim, or really there are two major claims I think that are rather problematic, which is that, and the biggest one is that they've claimed that they can make a timestamp instantly.
Yeah, you know what, Peter? We had a. I was talking to you on Twitter publicly, and you're saying, did you care about the latency, or did the latency bother you, or whatever? And I said, what are you talking about? The API responded like immediately, and then you were like, I think what you're trying to say was what I got back from the API request wasn't anything like what you would consider an actual timestamp.
Exactly. Yeah. And it's actually a very simple thing, which is that, and I mean, here, I'll give you a quote from the Tierion token sale white paper.
Oh, here we go.
Chain point responds immediately when a hash is submitted. Then also like Zaki Manian
which me being so stupid, as a stupid developer myself, I would agree with that.
Yes. And that's a real problem because you would get a very wrong impression and you would find that you couldn't necessarily validate what you got back.
No, but I wouldn't want to validate it until it can actually be written in the Bitcoin blockchain. I can give a shit less what the mousetrap is before that.
Well, so this is a problem. I mean, and I'll give an example where this actually really matters, which is, let's look at say Open Timestamps is Git integration. So with Open Timestamps right now, and actually this has been working for nearly a year now, you can go timestamp Git commits. So essentially, when you sign a Git commit, in addition to the signature Open Timestamps, then on top of the signature Open Timestamps, then puts a timestamp on the signature in the Git commit, which lets you go verify, in particular, that the signature is valid even in the future, say after the key is revoked or something like that.
Okay, I'm just thinking like we're getting to like the slice of the circle of like Venn diagram of like people who actually care about timestamping and then people who care about this actually being like fraudulent, like a Git commit.
I have a funny story about Open Timestamps. It's still true. I just checked. Okay. Peter, Todd, there's like a bug on your website, so I'm not sure what's going on. If I go to opentimestamps.org and I drag and drop my document in, and then I get my OTS thing, and then if you try to check it, it gives you another one that has the OTS appended twice. And this, I've only ever tried this on a Windows machine. I don't know.
No, I the same thing happens to me on Mac because I was looking at this yesterday. I figured it just hasn't been written to the Bitcoin blockchain yet.
Well, see, that's what I was wondering about. So I have like a funny bug. See, because I've actually
I don't know if that's a bug.
That wouldn't surprise me. I mean,
but that's not a bug, is it? That's just how your system works.
Well, so to be clear, so the way it should work is you click timestamp after opening up the file dialog and uploading your hashing your file, and what it should then give you is a download dialog for a .ots proof, and then when you go through that process again, but this time click both the file dialog in the proof dialog and then hit verify. That should go and verify the proof against the file. Now, if that doesn't quite work, I mean, let's face it. I didn't go write that code, and
I think it doesn't work.
I know it hasn't.
But I think actually you should fix it because probably most people use the website. Most people are not like us. They will only use the website and they will only use it in whatever it is. So I think just FYI, you have like a very funny bug because not only does it not work, but then it gives you another thing like whatever.txt
OTS. It says for me failure pending or bad attestation or whatever.
Still pending.
But see, the funny thing is that I noticed because I was preparing for this also, that Tierion had like a public website too, but I think I couldn't find it, so I think they removed it. So you get the only game in town if you have a working website.
So let me get back to my Git thing for a second. Which, so again, like. On that website, of course, you saw how quickly that happens. And the key thing with Git is that you need to actually create a verifiable timestamp proof that'll be verifiable in the future in a very short amount of time to make the user experience work. Because you want to be able to hit, git commit, and you want to have your commit made. And you don't want to have to go touch it again. And since the timestamp is in the Git repo, you don't have an opportunity to change it later. And open timestamps can do this in about a second because of the calendar system. That's what lets you get a reference to a persistent thing that should exist well off into the future, indefinitely, and you should be able to verify your timestamp later due to that commitment in a calendar.
So I don't want to get too far off on a tangent, but I just wanted to ask, because we were talking about client-side attestation of a timestamp versus resolution, all that jazz. So I don't know if anybody here has read about Google Spanner and the work that they've done as far as reconciling different, because this is kind of blockchain related too, ish. Right, not really, but what it does is it reconciles its differences in timing of changes in database by GPS timestamps in data centers. So has anybody else heard of this Google Spanner?
Yeah, and that's not a uncommon technique. There's nothing that novel about that.
Oh yeah,
but
I mean the question is, could you use a system like that where you have a certain degree of trusted, consensus as to the timestamp of something was created by a group that each geolocates data, whatever, in a cloud environment where you could actually timestamp something accurately and then hash the timestamp?
Working on an open timestamp.
Oh, okay. Well, interesting. You want to tell us a little more about that?
Well, I mean, that one's just dead simple. Like, that's just an example of a trusted entity that's signing a message saying, "Hey, I saw this, digest at this point in time." I've got a slightly novel take on it, which I'd like to use something called disposable keys to, if everything works, make it impossible for that trusted entity to re-sign those messages at a later date because they've literally thrown away the keys associated with that particular time slot. But there's nothing particularly novel there.
Yeah. No, I was just wondering about, an integration of something like that. Yeah. I realized, it's not like a ridiculously novel idea. And what they do with Spanner is actually much more than that. But because they do it.
Yeah, well, again, Spanner has a consensus issue, right?
Yeah.
Open timestamps isn't trying to solve consensus. And since we're not trying to solve consensus for that particular example of trusted timestamping, again, just like the calendar system, I'll have a set of completely independent trusted timestampers run by different entities that do not talk to each other.
And so if you have a trusted timestamper, instead of relying on the resolution of the blockchain, you can take the trusted timestamper, which falls within the resolution of the blockchain, timestamp it, and throw that in the perf. And then you know exactly when it was.
Yeah, in open timestamps designed to be able to represent proofs like that. In particular, it's designed to be able to also timestamp those signatures in Bitcoin, so that in the future you can go back and verify that the trusted timestamp was created or approximately when it claimed that it was created.
Right. So it fits within the transaction window of when it would have been timestamped. So you can reasonably say it was then.
Well, not so much the transaction window. More what you want there is to go show that, for instance, if a trusted timestamper becomes untrusted in the future,
interesting.
Maybe it gets broken into or something, or produces some nonsense. Then you can go show that this trusted timestamp was created well prior to when we think the system became untrusted.
That's a good point.
By having both disposable keys and also Bitcoin, we provide two very different mechanisms to ensure, the timestamps remain valid.
God, I think, anyone who's listened this far, I'm thinking they're dozing off by now. We're talking about
I
time.
live for shit like this.
We're talking about timestamping. Hey Peter, I'll be honest. I'm not following you on why. It seems like you're proud of the fact that wait, what? Oh no, it seems like you're proud of the fact that it's like we're not doing consensus. My service can stand on its own, but isn't that like entirely less efficient? And like, isn't the whole point you want to like do like a global kind of timestamping resolution thing where it's like really cheap?
Peter is just saying that his is robust to all this craziness that we have going on right now, where his is just something that works with Bitcoin. It just works. It's like Apple, it just works.
Yeah, but I mean,
so let me ask this.
I'm not really understanding why I'm not really understanding why you wouldn't want to like combine like all these Merkle roots and stuff together and make one robust kind of, I guess you would call it like a centralized system of timestamping.
Do you see my point though, that for timestamping, it can tolerate n-1 failures, right? Because you only need one of these calendars to actually go work, get your timestamp in Bitcoin or your timestamp proof to be valid. Whereas the moment you add a consensus system, consensus algorithms fail when they don't have a quorum.
Yes, exactly.
So
to keep a minimum amount of servers is crucial. Just how it's crucial to keep a minimum amount of servers for what you're doing, which is one. I mean,
yeah. Well, that's
I would agree. One is the minimum amount of servers.
So I'm just saying, like, it doesn't matter because people spin up stuff in the cloud and they can run like 50 nodes. It doesn't matter.
It's not that simple though.
Well, if you're using something like if you're using a tool like Mesosphere, Triton, Kubernetes, then it actually becomes a lot easier though.
I hate to push you on this, but like I don't think you're thinking about the threat models I'm thinking about. For instance, I want the system to work even if the people running these calendars aren't cooperating with each other. I want the system to go work when there's disputes about what the hell open timestamp is.
But isn't that the whole point? We're using the Bitcoin blockchain, so it doesn't matter what is going on before that. Let's make the most efficient mousetrap before we peg to the trustless system.
But this is precisely my point. In the client-side facing architecture, we should go and have a system that tolerates that much failure and doesn't need that type of consensus. Now, at the same time, we can make the calendars more efficient by leveraging consensus on the back end. And I'm sure that'll end up happening, right? But from the point of view of the user, they don't need to know this is happening. The way open timestamps' proof format works is if we choose to do that type of consensus, we can, the proofs already support it. They don't need to know that actually we're all timestamping with one transaction. That's not relevant from the user's point of view.
All right. So I'll be honest. I wasn't able to do my mini hackathon last night and do OTS. Now, let me ask you: Am I required to download the entire blockchain to use it, or can I offload that to something else? I wasn't very clear on that when I was looking at OTS.
Well, so the way the Python Open Timestamps client works is it expects you to either have a Bitcoin full node, or be able to go and query one you trust.
Okay, so I wasn't able to do that last night. I apologize because I said I was going to look at OTS before this interview or this episode, but essentially,
yeah. Now, point being, like that's basically just something I'd like to go do some more work on. I've got some ideas for how to do light clients, but that hasn't been the highest priority right now. And you can also verify time.
Sure, but wouldn't you say that now, because of the system that you developed with OTS, you now have to have more of a smart client? Because, I mean, obviously, you said n-1 failures. You're going to have your client be smart enough to switch or fail over to other servers that you have. I mean, isn't that kind of like an anti-pattern, or is that a pattern that I'm just not familiar with?
The code is actually dead simple, which is that when you make a timestamp, it's that's like literally what the Python code does. it makes multiple timestamp requests in parallel, and that has a timeout associated with that.
Whoa.
Provided.
Wait a minute. Wait, you just said something I did not understand. When I use OTS, I'm hitting a couple servers or more than one?
Yes.
So that means
by default 3 of them.
Okay, so that means when I use OTS, I am essentially making 2 pegs against, or can we just call them anchors for simplicity?
Timestamps.
Or making, all right, timestamps. Sorry, I come from a database background. Timestamp is nothing but a field as a field type in a database. So I don't know if my Casey agrees with me. But
No, I get that
This is not what
connotation. I
privacy
feel that.
calls timestamps.
Yeah.
All right, anyways.
For years.
All right, so as far as timestamping goes, I potentially am making 2 timestamps against Bitcoin when I make one request to OTS. Is that true?
Yes, exactly. Yeah.
Okay.
Yeah.
So to me, that's like double redundant. Like you're wasting a transaction fee, right?
No, I'm not though.
Oh, you're already making. All right, so you're making 3. All right. So you know how you said like every 6 hours or a couple times a day, you're pegging again or you're timestamping.
It's a flat 3 transactions.
So you're making 3 transactions a day.
Or whatever.
To Bitcoin instead of just one transaction. Okay. It seems like to me that you could easily combine those Merkle roots into another Merkle root and then just save the money.
But remember, like I explained, you can, but the client doesn't need to know that's happening. All right, and there's a subtle distinction. I can make that efficiency improvement without it being a part of the protocol. All right.
Yes.
Say if I run one of these calendars, it can ask its buddy, "Hey, could you timestamp this for me?" And if that other calendar successfully completes the timestamp in Bitcoin, it can then add that proof to its calendar and return it back to clients.
Okay.
The clients don't need to know that actually happened in the background.
Oh, of course not. They just need. Okay, so would you just say like that's something that is going to be done with OTS later down the road, or?
I probably will, although frankly, given that it looks like we'll likely be able to do timestamps for free without paying a transaction fee with SecP 256.1 commitments. That's probably the thing I'm going to work on first.
Yeah, because then you could expect one in every block, essentially.
Well, no, because he still has to. It's still a fee. It's just less of a fee.
No,
right?
no. It's somebody who's already doing. If
you mean like
client,
okay.
Somebody
I see
who's
what you're
already
saying.
doing it mutates their signature.
Check the box. Check the box.
And it's free.
Yeah. Okay.
Yeah.
So, is there any money in this? Is there any money in timestamping?
Heck no. That's precisely what my goal
I think
is.
that's his whole point. That's his whole point. There's no money.
There's no money in this. So, Paul, Peter, you're just doing volunteer work with OTS.
Yeah, to be clear, I've been able to get people to donate to this, which ultimately ends up paying me. But like the amount of money we're talking to date is like $10,000. It's nothing.
Okay, that's very interesting.
I'm doing this because I think the world should have timestamping that actually works.
Yeah, Paul, Mike, any more questions for Peter with OTS?
No, I think that was very enlightening in general. The only question I think I have is like, how robust is your API, and is it easy to take like a mass sum of timestampable documents?
Sure. Like if I was going to hit obviously it sounds like OTS couldn't handle like 1 million transactions per second, but what is your threshold, would you say?
Well, so timestamps are highly scalable, right? And all I have to do to handle 1 million transactions per second by, say, 1 million different people is add more servers to it. All right? Because I can have a calendar server that maintains a calendar, but it doesn't need to be publicly facing. You can put a layer of aggregation servers in front of it that both cache the calendar
or services, yeah. Like
it's mirror it.
Like if I wrote a service for OTS and I aggregated 10,000 transactions and made my own Merkle root and then send it to OTS as one transaction, is that what you're saying?
Yep. That's exactly it.
Okay.
Yeah. And frankly, this isn't too much work. We'll get around to writing that one of these weekends, especially now that Chainpoint's making some rather inaccurate claims about this stuff. But it's proven technology. We know it can be done.
Can you just go into detail about the inaccuracy of the claims by Chainpoint, if you could?
Yeah, well, we kind of got sidetracked when I was talking about latency, but so again, remember my example of a Git commit. So with open timestamps, because the calendar is about 1 second, we can create a timestamp proof they'll be able to verify later in about a second. Now, the claim that they've made is that A, Chainpoint responds immediately, in like a matter of milliseconds, and B, Zaki specifically made the claim that, I'm going to get the exact quote.
And also,
open timestamps was essentially quite low and very high latency.
when you say 1 second, are you saying you can respond and say, hey, it's on the internal calendar within 1 second? Is that what you're essentially saying?
Exactly.
Okay, so why do
because
I...
the interval between commitments on the calendar, the number I've chosen right now is 1 second.
But why do I care? Like, why should I care about your internal calendar? Because I essentially have to trust you for that calendar. What I really care about is when that's written to the Bitcoin blockchain, right? Or why does that precision matter, I guess, before it's written to the Bitcoin blockchain? That's what I don't get.
The point being is that because this is a public data structure that anyone can mirror and anyone can, timestamp themselves, you have the ability to audit the fact that these calendars are actually doing their job. So 99.99% of the time, you can just trust them to go do it, and then you don't need to, for instance, update your own timestamp groups. In the case of something like a Git commit, that's really important.
So
and
right,
the other
I was going to say right now I can set up I can on my computer I can mirror your calendar, or do I have to be part of your network? How does that work?
No, you can mirror it.
Okay,
I mean,
then
literally it is available as part of a server through HTTP, and you can just download the whole thing.
Okay, and then as soon as I make a commit to OTS, I can look on my calendar service that I'm mirroring and make sure that it's actually part of it. And when that, so I can trust essentially the OTS calendar. I mean, granted, you don't necessarily have to write it to the blockchain, but when it is, I don't know. I guess I'm struggling to see, like, I mean, I don't know. It's essentially a trust. It's like a trust network, and then when I write it to the Bitcoin blockchain, it doesn't really matter.
It's a bit too complex.
Maybe.
Remember, like, a lot of the use cases for this stuff is I am not convincing myself that I timestamp something. I'm trying to convince someone else. So I want to be able to.
Yeah, I know, but now you're saying that someone else can mirror that calendar and then trust it as well too, right?
Yeah, I think you're using the word trust weird here.
Okay, maybe.
All I'm saying is that because this is public infrastructure, it's very easy for people to observe that it's working, verify that, and if it stops working for any reason, go timestamp it themselves, to make sure that these commitments actually get timestamped.
But I mean, what do you mean by I'm sorry, define working, because working is in producing accurate timestamps, because even
working as in producing timestamp proofs verifiable back to Bitcoin.
Right.
In the future, accurate timestamps too, but like my Git commit example, I want that commitment in the Git commit to get timestamped in Bitcoin, in a reasonable amount of time, and I want to be able to get that proof so I can later verify it and later convince other people. So because it's a public data structure, anyone can verify that.
Git's an interesting example, because Git commits could come in one right after another, like immediately. You could, yeah. So how do you determine? I mean, because we're back to the basic transaction ordering problem that Bitcoin kind of solves through consensus.
I mean, this is a very complex question to answer, actually, because there isn't a good way to make that transaction or ordering proof that you want. What open timestamps promises is simply that it will show that your Git commit existed before a point in time.
Right, exactly.
And that's actually all that's feasible to go do.
Okay, yeah, that's an important point, though. I mean, and I agree with you. That is all that's feasible to do, but it doesn't help you when the resolution of your Git commits exceeds the ability to properly timestamp them, because you still don't know which one came first.
But hang on. But remember, the timestamp proof is simply showing that your Git commit was made in the past. Right? Why are you then, like, what are you trying to do to go show that, say, one came before the other?
Well,
that's in Git itself.
I don't know. I'm just saying, if that scenario came up, then this would not be an applicable resolution for that.
Well, I mean, my bigger point is that, you need to go come up with an actual rationale for that, and B, what you'll find is that resolution's illusory because it's actually very difficult to create that type of proof. You actually need to embed commitments inside your data structures in irrevocable ways.
Which was why I kind of brought up Spanner, just because it's kind of the same deal there. Yeah.
Hold on, real quick.
But Spanner isn't cryptographic. Remember?
Well, that's true. It's not.
Spanner has a very different problem domain. When you add cryptography to it and try to make cryptographic guarantees, like I say, this stuff gets very difficult.
Hey, Peter, wouldn't you say that OTS is just essentially making a trade-off where versus Tierion, where, because I was thinking about this, you're essentially just making a trade-off because you're not using consensus and you're not making like a more, I want to say it, to me it's like a more efficient system. You have the ability to timestamp more often versus like you're saying they're not really giving you a timestamp when they reply immediately, but they timestamp less often through their internal calendar. They have less precision on their internal calendar, but to me it's a trade-off. It's just like they have more efficiency of like scale to me. Now scale is a weird word with timestamping because like obviously you can scale different ways, like aggregating Merkle roots and then setting them up. But I'm talking about as far as their flatline core service. To me, it's just a trade-off, right?
But keep in mind, why does the user care about what they're paying? The difference is trivial either way. It's a bit more, a bit less data. And that again, the big thing though, that I kind of want to get back to is they were making the claim that their system has lower latency. When in reality, they're not talking about the latency to get a verifiable proof.
They're talking about a response time to their API for the initial hash ID or UUID or whatever.
Well, it is an important distinction, but I mean, both are important because you want good latency to an API.
Yeah,
you
don't want like an API service to take a long time. Typically, if you hit an API, you want to almost like near immediate response. Typically. Now, for your use case, it sounds like you're bringing back more useful information when you actually do bring back information. And to me, that's just a trade-off.
My point that what that API produces isn't actually useful, right? What you could have done instead is locally had a thread, get these API requests, at say 10 a second or something, and then do the somewhat higher latency with actual proof thing from open timestamps.
Yeah, it's a trade-off.
What you actually need to do is go back.
Peter, don't you understand? This is just a trade-off. I mean, this isn't better. Your system isn't this specific point of latency isn't better or worse. It's just a trade-off because what they're doing is giving you a pretty much some kind of receipt similar to what you're doing, but then you can get the better proof later.
But do you understand my point, though? That
I understand what you're saying. You give back more. You're saying
claim, which is that their system has low latency.
Yeah,
but it has low latency that doesn't actually do anything.
It has low latency for receipts, not proofs, is what you're saying. Well, which is a fair.
It has no. So it has low. Yeah, exactly.
Right.
Okay. Hold on.
Proofs.
Is that what you would say, Peter? They have low latency for receipts, but higher latency for proofs, right?
And receipts are useless.
Okay.
The only thing you do with a receipt is go back.
At a later
time later to go get your actual proof. And you have to have a process in your system to do that.
Exactly.
Well, to me,
I did that for my hackathons.
Well, this smacks of Bitcoin actually, because it's TX broadcast versus commitment to a block. It's how quickly does it propagate as a broadcast transaction? You can actually see it on your client versus how quickly does it actually record in the blockchain. It seems like the same thing to me. You want low latency on your broadcast. You want that. It's like
Peter, like no one cares. Like it's funny if Joseph listens to this podcast, he's going
shitless.
Joseph already thinks timestamping is stupid. And like the fact that we're talking about latency of the proof versus latency of just the response for the receipt, like no one gives a shit. I don't think. I'm a developer, and I was doing hackathons using Tierion because I didn't know about OTS, and this didn't affect me at all because all I do was batch processes. I would have 3 queues, one for the receipts, one for the proofs, and one when it got put into the Bitcoin blockchain. I would just batch them. And to me, when I'm writing a system that's getting hit by IoT, because that was my use case, where I'm getting thousands of, whatever, I'm hitting their API thousands of times per second. I'm batching all this shit. I'm not actually waiting one time per second, for my response. So to me, it's just a trade-off, Peter. I don't know why that's like not why you can't agree to that.
But again, like, do you get my point though? That
I get
they
it.
made a trade-off.
It's a trade-off.
But then they lied about what they did.
Oh no, I'm not talking about whether or not they lied or not. I'm just saying it's a trade-off.
So I just want to do
Keep in mind, like, open timestamps is designed as a trade-off. I didn't pick 10 seconds. I picked 1 second because I did the math. Figured, all right, the amount of data 1 second produces is, I think, acceptable to mirror.
So I just want to get back to you said the claims. So are those all the claims that they made in their ICO that you contested, or are there any more?
Oh, yeah.
They're
important ones
are more like the NTP timestamping. But the big thing with their ICO is they didn't actually make very many claims at all that you could concretely refute.
No ICO ever does. I mean,
yeah.
Peter, we're not big ICO fans at Blocktime. Just FYI.
Yeah. Like I wanted to do a very solid job of refuting something that I could do a solid job of. That was
right. I just wondered if you had any other ones that you wanted to talk about, just to give you good time to talk about them.
Sure.
Or is that those are your main ones?
Well, the NTP timestamping one's interesting, which is that the way that they've written their documentation, and I think they're backpedaling on this a bit, is they're making claims that they have high accuracy component to their system. For instance, that the hash ID that they return has a time in it, and the way they talk about it using the word timestamp, of course, implies to users they can actually trust it.
There we go back in the definition of a timestamp.
Let's just all right. For this podcast specifically, let's say timestamping means the verb, not the noun. Is that fair? Or am I?
Well, that's what Peter's definitely talking about. Yeah.
So we're not confused. We're not confused. Let's talk about timestamping being the definition of verbing.
Well, he's saying like a timestamp as of a date certain.
Yeah.
Where you can trust it, right?
Well, I think data, timestamping the data.
Definition of a timestamp.
Okay, so the cryptographic
a timestamp is both a noun and also a verb.
Right, it's a noun and a verb, but you're saying a trusted timestamp.
I think Peter's saying like you have to timestamp data for a timestamp to be a timestamp.
Yeah. My point is that the hash ID that they return is not linked to data in a way that's cryptographically secure. An attacker can create a fake hash ID that says anytime they want.
Can you go over a use case where this would be an issue, like some kind of man in the middle attack? Is that where you're getting at as far as like a vulnerability?
But remember, timestamp proof, what you're doing is you're trying to convince someone else, either someone entirely different or perhaps you at a much later date, that something happened, as of a certain point in time.
All right, so
you're not trying to convince yourself. This is why like a man in the middle attack isn't actually all that relevant to this.
But Peter, I'm sorry, but no one cares. I mean, the mousetrap before, like this calendar service that you or Tierion has, or whoever else does a calendar service, it's really like how it gets pegged to the Bitcoin blockchain. That's the cool part, right? So, right? Or are you saying that you would potentially miss out?
Misunderstanding this.
I probably am.
There is a subset of people who do care because they actually have these use cases.
They need the high granularity timestamp, and essentially, so why even peg against the Bitcoin blockchain at all, or why is that necessary?
Well, like I explained prior, if you have an actual working high resolution timestamp system, it makes a lot of sense to further timestamp those timestamps in Bitcoin to show that they were made prior to some attack event.
Okay.
Right. It provides remember, timestamp proofs are additive, right? Everyone shows that something is true, and between multiple different proofs, you're just getting a better protection against attacks, and potentially better resolution if some of them have better resolution than others. And by having multiple timestamp proofs, particularly this timestamping a timestamp proof, you are preventing different types of attacks that can go happen.
Okay. Well, I'm about exhausted with timestamps, Mike. I don't know about you.
I mean, honestly, I don't think we can go on to drive chains and do it justice this time around.
Well,
honestly.
I don't know, Paul. Are you up for a drive chain deep dive?
Well, I think that I agree that we really shouldn't do it. I think we've already gone for like 90 minutes.
Yeah. So
Maybe
next week,
Next week.
no guests. So I would like to, Peter. Thank you very, very much for this. This has been
Well, let's let Peter finish with anything
Yeah.
else that he wants to talk about.
Any last comments?
Because I do want to talk about. He did make a tweet that I saw earlier about BTC1. I did want to hit on that quickly. Peter,
the whole
can you give us?
Oh, like the BitPay thing.
Yeah, can
Yes,
you
yes,
tell
yes.
us about that? Because obviously, we're in Atlanta. We're right next to BitPay. This is close and dear to our heart. Tell us what is going on? Why is everyone calling them a fraud? What is going on here, Peter?
Well, I mean, what they did is they gave instructions to their, clients and users to go and with the instructions saying that they needed to do this to activate and to use SegWit. What they actually did was link to the BTC1 repo, in the forked 2x software, without telling their users what would actually happen.
Yeah,
like right there, like had some user downloaded that software blindly, they could end up on a currency that they were not expecting, at some point in the future when activate.
But isn't that just them fulfilling their agreement to the New York agreement? I don't get why they're calling them fraudsters. Like, as far as like, this is what they're planning on doing anyways in November or whenever 2x is going to be happening.
Because you have to inform your users what you're doing.
So
you to not go mention that this software
Interesting.
changes the consensus rules to a version of Bitcoin that at best is highly controversial. That's ultimately putting your users.
Unless that becomes a version of Bitcoin.
Hold on, you're saying at best highly controversial. Everything could be considered highly controversial. I mean, so the biggest thing is it all goes back to the definition of what you define Bitcoin as.
Mm-hmm. I think it's important to inform your users, but I think also that probably most of the users have no idea what's going on at all.
Right.
So I'm not sure how informative any of it would even really be. I mean, I agree that steps should always be taken, but it's kind of a lost cause. I'm not sure how I feel about it, really. I know everyone wants to hate BitPay, but I don't really know what they should do.
Legally speaking, I mean, that puts them in an even worse position. For them to not tell their users anything when they know that their users aren't all that informed. But I mean, if you install that software, you can end up losing a lot of money.
Well,
I mean, it's as simple as that.
But what happens? Okay, so obviously, I don't know if you know about our history of this show, but we used to have someone on
our
here
former
from BitPay.
Co-host was actually one of the BitPay employees that implemented SegWit 2x.
Which we will not
the
name.
show that was too interesting.
Yeah, we will not name this said person, but essentially, to me, it's clear that if 2x actually takes over and has more hashing power, that will be the new Bitcoin. And then core,
that's a big if.
Okay. Then we agree to that. We agree to that.
So would you say that if SegWit 2x does in fact garner the majority of hash power, it would be Bitcoin?
Then they're not frauds.
No, I'd say they're still frauds.
Okay, well, no. I didn't ask that. Let's back up.
Which is that they need to inform their users of what their software does.
So,
it's important, even in that case where you agree that the new Bitcoin's whatever, you're still gonna have another chain that's worth something.
Well, yeah, but I mean,
I'm still having money lost from
right. Okay, so let's back up from the fraud claim for a second. I would just like to ask you, point blank, would you personally consider if it say garnered over a majority, say 80% of the hash rate, would you consider SegWit 2x to be Bitcoin?
Hash rate has nothing to do with that.
Okay, so you would not.
I personally think that I kind of agree with BitPay. Like, I'm not saying I'm a big BitPay fan, but the chain with the most work on SHA-256 to me is Bitcoin at the moment, as I currently see Bitcoin.
And like I said, this all depends on your definition of how you define Bitcoin.
There's a lot of cases where I think you would disagree.
Well, obviously, if the limit
if
the limit raised over 21 million,
if somebody messes with the supply curve, yeah, definitely.
If someone messes with the issuance or some kind of weird difficulty. I mean, yeah, I would agree.
They make it
People
so
to run
anybody
full
can
nodes,
spend
like,
any transaction or whatever. You know, it's like, yeah, there's lots of reasons. Yeah. But by and large, if you know, I don't know. My opinion is if it follows the white paper of Bitcoin as written, and it garners the majority hash rate, then I consider it to be Bitcoin. That's my
The
stance.
white paper of Bitcoin
Okay,
does
well-
not have anywhere near enough detail to even describe Bitcoin.
Which
Right.
makes it perfect for
Right,
this.
agree. I say anything that fits that definition, as loose as it is, because like if you change the supply curve, you're not conforming to the white paper. You know,
The white paper doesn't mention supply.
It doesn't mention having a 21 million cap.
That wasn't in the
Yeah,
white
that's
paper.
not in the white paper.
Oh, I didn't know that.
I thought it was.
Okay. Oh, that's interesting.
I thought it was
Bestowing knowledge.
I forget.
Yeah,
It's been a long time since I read it.
The way that currency is distributed from a technical perspective, there's a lot of completely valid choices out there.
All right,
That's
let
true.
me ask you
Good
a
point.
question, Peter. Is the one, in your opinion, obviously there's no right answer maybe to this, but in your opinion, is the 1 megabyte limit of block size, does that define Bitcoin?
The exact number is less important than the fact that we're not raising it quickly.
Okay.
So, well, let me ask you,
You know,
this.
like 2x goes from a maximum, 1 meg per block to approximately 8 megs per block, is what the combined total 2x and SegWit does.
Correct.
Like that's, under many threat models, that's a pretty dangerous thing.
Okay.
And the plan for the 2x people is to repeat this again in not that long.
So
It's a very different philosophy to scaling.
yeah, no, I understand. Yeah, because that doesn't jibe with your philosophy of scaling. As I said before, you have one contingency that's about optimization. And that's not an optimizational approach. So I have another question.
I'm not sure optimization is really the right word for this. Lightning isn't an optimization. It's a fundamental change the way scaling works.
Well, right. Okay. But I mean, if you're saying it's a fundamental change to the way that scaling works, then I mean, it gets to the point of, okay, is that really Bitcoin then? Because it's a fundamental change. I mean,
but the important thing about Bitcoin is that, the whole stuff, but you are your own bank. It's decentralized peer-to-peer currency. That's what makes it different from other systems. To have a system where it's increasingly harder to actually fulfill that role, I don't think is Bitcoin. I don't think many other people think it's Bitcoin.
well, yeah.
I mean, after all, quite
that's the thing.
concretely, the reason why this whole 2x thing even can be controversial is because tons of people run full nodes and will reject it.
Well, yes,
You
but
know?
I mean, any full node can reject anything from any blockchain, and they just kick themselves off of the network. I mean, so you can run a full
But the
node.
point is, but you're asking us the wrong way around. Think the opposite. If you don't have a full node, all you've got to go by is hashing power because you can't verify.
You can't verify the individual transactions because you're trusting other nodes. Because you can have
Well, you're trusting miners ultimately. I mean, you can't trust other nodes because you don't know who they are.
Well, that's true. You can sample a population of them.
How do you know what the population is?
Well, how does your full node know what its population? It's vulnerable to a Sybil attack just the same.
Point is, though, Bitcoin's actually quite resistant to Sybil attack. Bitcoin does very well against Sybil attack because of
Well, yeah.
work.
As long as it sees one valid other node, then it can reconstruct the entire blockchain.
And remember, you said sampling, right? Sampling doesn't work in that threat model.
It's an interesting thing. Yeah. Because I've often wondered how SPV fares versus a full node under a Sybil attack. So
the SPV does really badly. At least with a full node, you can do things like verify that the transaction spending coins that are real. SPV can't even do that.
right, and because it
And more
validates the actual
generally,
blocks.
there's bigger issues there about where does Bitcoin go in the future? The whole reason why miners do roughly what we want them to do is because we buy their coins knowing whether or not they go fulfill a protocol.
Incentive.
If that breaks down,
Well, okay. I agree. I agree that the user base does legitimize the mining power, but I honestly don't think that something I mean, philosophical aside, is something as trivial as the 1 megabyte cap on the base block size is something that would violate the social contract that is Bitcoin enough to have them ditch the majority of hash power should it go to the other chain.
Hashing power is just something that goes and works for us. And again, like ultimately, that cap is a big part of why you can participate in Bitcoin. Without that cap, you would not be able to easily run a full node. Maybe you wouldn't be able to at all.
So let me, well, I mean, this is arguable in the future because we don't know either way, honestly, because we can't.
I want to ask him so bad what he thinks about Ethereum later.
So here's my other question. So should that happen? Say a majority of hash rate goes to the SegWit 2x fork. Would you then advocate under any circumstance a proof of work change for?
Oh, absolutely.
Okay. So then we were left with 4 Bitcoins.
The community to have, to the extent they can, concrete plans.
But
so that's
what would it be called? Would it be called? I don't think
what would you call that?
Well, this is where things I think get interesting socially. I mean, I think there are mechanisms by which you could make a good claim. This is what should be called Bitcoin. You can do things like, for instance, show economic support by people signing with their coins and whatnot. But even if it isn't called Bitcoin, again, you can still have a situation where miners wind up destroying the value of their expensive ASICs.
Well, I mean, if you look at even Bitcoin Cash, I mean, it's been holding its own of recent.
It's only up like 100% in the last 2 days.
So, I mean, they're not necessarily, anybody who mines the other chain isn't necessarily destroying their value because what's been proven is both sides of a fork can increase. I mean, granted, it dropped from the value of Bitcoin at the time. I think it was like 35.
I think you have to have crazy
down to.
I think you have to have crazy people like
it survived.
You have to have like a Jihan Wu on the other side in order to have people maliciously mine or
the point
attack.
The point is, it survived. It didn't die, so it could potentially therefore grow.
Like you mean like?
I mean, keep in mind that with Bitcoin Cash, you still got a relatively thin market. So it's obviously it's possible people go sway this. Plus, in general, for difficulty, it would actually be really surprising if Bitcoin Cash didn't end up being roughly as profitable as Bitcoin for miners.
It actually is as of now. The difficulty is adjusted. I think last I heard, it's actually slightly more profitable.
That's how difficulty should work.
Yeah.
What do you mean, Peter? What do you mean slim markets for Bitcoin Cash?
Well, I'm saying that the amount of people who've actually got in a position to go sell their Bitcoin Cash is still a relatively small percentage.
I'm just looking at CoinMarketCap. It's $3 billion.
No, he's talking about places that accept Bitcoin Cash. So that brings up a very
no, I'm not.
You're talking about selling on exchange. You're like
sell it.
Okay, selling on exchange.
Yeah, but right now the volume of Bitcoin Cash is $3 billion. Bitcoin is $2.8 billion.
So
but that $3 billion is double counting. Remember, because that volume includes multiple trades. I'm talking about the volume of people, the supply of people who are actually in a position to sell their Bitcoin Cash.
All right.
Well, isn't it the same as Bitcoin pre-fork? I mean,
pretty much.
People actually have to have the software.
That's true. That's true. Because you have to have a wallet that's able to separate and distinguish between the two coins. Yeah, you're correct.
I mean, as an example, like I've been contacted by people trying to figure out how they'll go sell their Bitcoin Cash out of, for instance, high security cold storage, with very large amounts of money. But do they want to go risk that? Do they want to go risk that cold storage with software that is coming from potentially untrusted people?
Yeah,
that's the kind of question a lot of people have.
I actually had a rather interesting conversation, and it was on our Bitcoin, and there was a guy, the Flare, and he actually made a very good point because he was talking. They were speculating somebody made a very, very large Bitcoin transaction. And it was speculation that it was a guy known as Loaded, who is like insanely rich, and he was saying that he's going to sell all his Bitcoin Cash, and I said, well, that doesn't make any sense. Why would it move on the BTC chain? And he said, and this is a very good point. This is a very good point. He said, well, yeah, if you don't move it, then you actually use the same. So say it's stored on a paper wallet or one private key. If it does leave you vulnerable to a quantum attack. if such a thing ever were to occur, if you leave it because it posts the public key
yeah,
to
I
the
would
blockchain,
say-
if you spend it
I
from
would
the
say
PCH
That's
side.
a good point. If you have,
So
I didn't even think about that. I mean,
yeah,
that's,
me
that's
neither.
True.
I
That's
didn't.
true.
I didn't.
If you have
the
a
more
lot of
likely attack is you making the keys vulnerable while you
right,
spend it.
exactly, because the public key gets posted, which you never
Yeah.
want to do if you don't
Well,
have
no,
to.
no,
Right? It's like
that's not what I'm talking about. I'm saying the secret keys in the process of getting new software in to go sign those transactions.
well, Peter,
sell those coins.
I mean, what?
Well,
I mean,
that's
I can
always
just,
the
I can
case of
just
any
send
Bitcoin
no,
wallet,
no,
right?
no. I mean, obviously, yeah, I might lose my Bitcoin Cash, but damn it, Mike.
shouldn't sit over here.
All right, we can't trust you with anything. All right, anyways, I mean, what? I mean, yeah, I might be risking my Bitcoin Cash, but I'm not risking my Bitcoin because I'll just send it to another like cold storage wallet or whatever.
It's not that simple though, because many systems, first of all, transitioning new cold storage is tricky because now you have to create new private keys.
We're going over that at our next meetup, by the way,
Yeah,
Peter.
well,
I would
yeah.
love for you to come to Atlanta. We're having like 150 people come out to learn how to make paper wallets at our next meetup, by the way.
That's how many of our
I really hope you remind people that paper wallets are often born compromised. The paper wallet is not the secure part that you should worry about. It's the computer that made it.
Well, yeah.
We're going to be making them offline with
yeah.
secure hardware.
So what's your
what type of secure hardware?
We're gonna produce these private keys in a bunker, air gapped, on technology that's never hit the internet.
It honestly depends on your.
And then we're
level
gonna
of-
burn. And then we're going to go to Canada and burn the computer, and then showcase it for Twitter to everyone to know. Wait, maybe I'm thinking of Zcash. Wait, hold on. What am I thinking of?
Yeah, and that's a perfect example. That entire process is frankly kind of dubious. Because there's a limit to like what you can actually do to protect this stuff.
Well, it depends on your level of paranoia, which I would fully agree. If you want to be absolutely secure, you should be rolling dice in something that has everything stripped out and there's can't possibly
that
generate an EM
actually,
signal.
The whole point
It's
of
like
the rolling dice part is looking at it from completely the wrong angle. That's not actually your threat. Your threat remains the software.
Right, well, yeah.
And again, this gets back to why selling your Bitcoin Cash is hard for many people, because they now have this risk of, for instance, screwing up the process of moving their existing Bitcoin. And if they don't do that, they have this other risk of that Bitcoin Cash software compromising their coins.
So,
and some of the Bitcoin Cash wallets have turned out to be theft.
by the way, Peter, I was very impressed with your.
Hold on,
wait,
that's important. which ones have turned out to be theft? That's kind of important for our audience.
Well,
of
there
three
was
people.
a fake Electrum wallet.
Okay, there's
one example.
What are you talking about? Electron or?
Yeah, because there's a fake. In addition to Electron, there's also
there was a
Electron
different
that stole a bunch of
version
people's
that was
money.
malware that stole BTC and BCH based on. I hadn't heard of that. Okay, cool, good to know.
Yeah.
All right, guys. Paul, I know you've been really. Are you asleep over there, Paul?
Paul's gone.
Paul's gone. Paul has left the building, even though he's talking to me on Telegram every once in a while. Anyways, Peter, I think you did great during this interview.
Yeah, thank you so much for joining us,
This
Peter.
was awesome to just chat with you for an hour and 40 minutes now. So
Yeah, if you're ever in Atlanta, let us know. We'll go have a beer or cider
Definitely.
or whatever.
Atlanta's a hub. We have conferences down here.
No,
and every once in a while it snows, so you'll feel right at home.
But
Well, maybe
again,
I'll make it down.
our special guest, Peter Todd. Thank you much.
Thank you for coming on, Peter. And Peter, if you want to give a shout out, where can people find out more information about you? It's funny. Anyone who knows about you probably already knows about you. They're not learning about you for
true.
the first time. But just in case, where can people find out more information about you?
I mean, it's hard to find information about me, but you can find stuff I've written on petertodd.org, my website.
Okay. And your Twitter handle?
Yeah, at Peter Todd BTC.
Okay.
Well, thanks again, Peter.
Yeah, thanks for having me on.
Yeah, man, it's been a pleasure. Mike,
All right.
with that, I think the nonce has been found.
And our blocks have been time stamped.
Thanks for propagating, everybody.
Bye.